Hi guys, on today's video, I bring the best news ever. So it's like I found a cheat code how to always get the equations right, most especially when you are solving those equations in your mathematics exams, assignments, or whatsoever. So the trick is to face the question, right? Like you have to face the question with confidence anyway, but then you have to face the question like you face it face to face like this. So now I want us to face 2.2 together. Now that we're still under the question series, by the way. Now that we've done 2.1 of the question, now I want us to look at 2.2. And then now we're going to do the trick together. We're going to face the question face to face. Me, the question, you, and the question facing it like this. Let's face the question. Enough facing, right? So now that we face the question, a question like 2.2 actually determines your understanding if you know your story proper under sequencing series. Point number one is they never specified if is it an arithmetic sequence or is it a geometric sequence. At this point, if you've been following our videos, at least everyone is expected to understand what is going on this table here. Arithmetic sequence and the formulas involved, geometric sequence and the formulas involved respectively, like that, right? So now that we face the question here, and the question states if the sum of that expression right there is equals to 21/6, and then they want us to determine the value of k without even specifying if is this a geometric sequence or an arithmetic sequence. But then to determine that, it's very easy. All you need to do is just to determine at least the first three terms. From the expression itself, you can derive the first three terms, and then you will know if you have either a common difference or a common ratio. We already know how everything is worked out. Now let's put it down on our board and see if we can work something out to simplify the whole thing. Now, for us to determine the first three terms from this expression, we'll find that T1. Now, to get T1, since P is equals to 0 here, I just have to take the 0 and substitute it on the P for the first term. So for T1, it's going to be 1/3, where this P I put 0, plus 1/6. There's going to be 1/6. Same applies to T2. For T2, it's going to be, now the first one, it was P is 0. Now I'm going to put 1 because now it's the second term. Now for the second term, it's going to be 1/3, 1 there plus 1/6. This will give me 3/6, and 3/6 is the same as 1/2. Same applies for T3. I do the same thing there. For T3, it will be 1/3. Now, since it was 1 here, now I'll put 2 plus 1/6. So this is going to be 2/3 plus 1/6. And then if you simplify this, now I understand you know how to simplify fractions. This will give us 5/6. So here is our three terms. We have 1/6, 1/2, and 5/6. Now, for us to determine if this is an arithmetic or a geometric sequence, this is what we do. If it's an arithmetic, for an arithmetic, we just have to prove that the common difference, if we calculate the common difference on our three terms, we have to find that when we take T2 minus T1, it has to be the same as when you take T3 minus T2. If we can prove that T2 minus T1 is the same as T3 minus T2, and then we would have proved that this expression is a arithmetic sequence. Now, for geometric sequence, For geometric sequence, we just have to prove that when we take T2, we divide by T1, we should get the same as when we take T3, we divide by T2. That's how we can prove if the expression is geometric sequence. So we're gonna start with we're gonna start testing if it's an arithmetic sequence. So this is what I'm gonna do. T2 minus T1. T2 minus T1 is gonna be 1 over 2 minus 1 over 6. What is the value? 1 over 2 minus 1 over 6. This gives me 1 over 3. Same applies when I say T3 minus T2. It's going to be 5 over 6 minus 1 over 2. When I simplify this, I get 1 over 3 again, which means it is correct. T2 minus T1 is 1 over 3 and T3 minus T2 is 1 over 3, meaning T2 minus T1 is indeed equal to T3 minus T2. And then I can conclude that this is an arithmetic sequence. If you want to prove this further, you can prove to see if T2 over T1 is the same as T3 over T2 to can check if it's geometric sequence. But then I assure you, these two won't be the same in this case. T2 minus T1, it won't be the same as T3 minus T2 because it's not a geometric sequence. We've actually proven that it is an arithmetic sequence indeed. And the common difference D is 1 over 3. And our 3 times is 1 over 6, 1 over 2, and 5 over 6. Let me write this properly now. So our terms are 1 over 6, 1 over 2, and 5 over 6, which is an arithmetic sequence with a common difference D, which is 1 over 3. And by now we know that the formula for the sum of arithmetic sequence is given like this. So we know that the formula for the sum of arithmetic sequence is given like this. That time we know the difference is 1 over 3, so we have the value for D. We know the sum given according to our expression is 21 over 6. Actually, I can write this as a normal fraction. If I write this as a normal fraction, this is going to be 121 over 6. To get this, we just say 6 times 20 and then plus 1. So it's going to be 121 over 6. So it's the same thing like that. So now, in this case now, I was just showing you how to simplify the mixed fraction. So we know the formula is given like this. So we have this value. We have the value of A, which is our first term. The value of A is 1 over 6. We just need to calculate N. And the relationship between N and K, which is very much important to know. You have to remember that N is equals to K plus 1. N is equals to K plus 1 because we moved from 0 and then 1, 2, like that. So we keep on from K, we keep on adding 1 to get N. So N is equals to K plus 1. It's important to remember that. So from here in this formula, we can calculate the value of N. And then after calculating the value of N, it will be easier to determine the value of K. So this is how we do it. I'm going to substitute from our formula here. So Sn will be 121 over 6. This is equals to N, which we want to calculate over 2 to the 2 into my A is 1 over 6 plus N minus 1 and D is 1 over 3 like that. Simplifying further, we'll get 121 over 6 is equals to N over 2 into 1 over 3 when I simplify this, because 2 times 1 over 6, 2 goes once and it goes 3 times into 6, and then plus N over 3 plus 1 over 3N minus 1 over 3. And then to remove the 2 here, I can just multiply by 2 both sides. If I multiply by 2 both sides there, then I will have n is to 1 over 3 plus 1 over 3n minus 1 over 3. And then here is going to be 1 to 1 over 3 because I've removed the 2 there. And then multiplying by n throughout here, you can see this cancels that because it's 1 over 3 minus 1 over 3, and then I'm left with n multiplied by 1 over 3n. This is going to be 1 over 3n squared, 1 to 1 over 3, like that. Because I need space, I'm going to move this to this side because we're done with this part. I'm going to move this to this side just to finish up the calculations there. So moving this one here, this will result in 1 to 1 equals to n squared, because 1 to 1 over 3 is equals to n squared over 3. So now this mathematically it can be written like this. And then now we just have to solve for n so we can determine the value of k. Solving the value of n here, we're just going to put square roots both sides. And then that's when we'll find that n, and then that's when we'll get that n is equals to 11. N is equals to 11, but then we are looking for the value of k. And then I did say that, don't forget to remember that n is equals to k plus 1. If n is equals to k plus 1 and n is 11, it means if we solve for k, I take the 1 to the other side, and then I'll find that the value for k will be 10. K will be 10. So that's the value for k. So this is how you calculate the value for k for this question. So just like I said, the type of equation we're dealing with here, it actually proves if you really understand your theory around sequence and series. There's nothing that beats practice. All you need to do is just to practice more and more and more and more to make sure that you understand the basics, so you can actually apply the whole thing. So I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. Join me on the next video as I simplify more academic content. All you need to do in the meantime is just to subscribe to our YouTube channel. Please follow us on Facebook, TikTok, and Twitter.